we're discussing how to determine the acid and the base and the conjugate acid and the conjugate base, otherwise known as acid-base conjugate pairs, in this video. And in order to understand this, you really should be familiar with the Bronsted-Lowry definition of acids and bases, how to figure out ion charges if you're passing a positive back and forth, and then have a general basic understanding of chemical reactions. The thing to remember here is that acids will lose hydrogen in a reaction to become a conjugate base, and the bases will gain hydrogen to become the conjugate acid. And so a general rule is that acids and bases will always be on the reactant side of a chemical reaction, and conjugate acids and conjugate bases are always on the product side. So you can think about this generally as being acid plus base will be going to conjugate base plus conjugate acid. Now, you might not always have a reaction where the acid is listed first and then it's all neat and tidy like this, but what is helpful to remember is that the acid will always become your conjugate base and the base will always become your conjugate acid. And what's nice about that is once you've figured out one of these, then it sort of makes everything kind of trickle into line. Let's look at an example. Identify the acid, the base, the conjugate acid, and the conjugate base in the reaction below. In order to do this, I need to look at what I'm starting with, for instance, HCl, and then I need to look over to the products and see what HCl becomes. And I see that HCl becomes Cl minus. And what I notice is that here I started with one H, and over here I have no H's, which means that HCl lost an H. That's the definition of what the acid does. So HCl must be my acid. H2PO4 negative, I start with two H's, and over on the product side, I form something which has three H's. And so H2PO4 negative has gained an H+, and that's what bases do. Technically, I can start in the products and go backwards and think about this in terms of Cl minus becoming HCl, in which case then Cl minus is gaining an H+, and so it is the conjugate base. And H3PO4 becoming H2PO4 negative and losing an H, and so we could consider this to be the conjugate acid. The other way I could approach this problem is simply to say, oh, I know what HCl became, and since HCl was the acid, it will become the conjugate base, and since we know that H2PO4 was the base, and it will always become the conjugate acid. Either way works, do what you're comfortable with. Let's tackle another one. We have NH3. I check the products to see what NH3 has become, and I see that here I have three H's, and in the products I have four H's, which means that NH3 has gained an H, which makes it the base. So that's NH4 plus is what NH3 becomes, it is the conjugate acid. HNO2, I check just to double check myself here, I see one H in the reactants and I see no H's in the products, which tells me that this lost an H. Oh, I should have made this blue. Whoops. Lost an H, which makes this my acid. And that makes NO2 negative 1 my conjugate base, because my conjugate base is always what the acid becomes. You might be asked to determine what the conjugate acid or the conjugate base of something is without the context of a reaction. And so it might be helpful to go back here and notice that when I had, say for example, my base, and it formed the conjugate acid, I always added one H+. On the other hand, if I had an acid, and I formed the conjugate base, I always lost one H+. So when we're looking at this question of what is the conjugate acid, that's implying that what we're working with is the base. So we have the base, and we have to produce the conjugate acid. Bases, we know, gain H+. So we simply need to add an H+ to each of these. OH- has a negative charge. If I add an H+ to it, that negative goes away and becomes neutral, and I make HOH, which is also water. If I add an H+ to PO4 -3, the phosphate ion, I get HPO4, and now my negative has become -2, because it's like I took the -3 and just added +1 to it. HSO4 -1 becomes H2SO4. If instead we're asked what is the conjugate base, that implies that we're starting with the acid. And acids lose H+. So that means in order to figure out what the conjugate base is, I need to take H+ away from what I'm started with. It's helpful when looking at something like HF to consider this as just the combination of H+ and F-. And we're simply taking away the H+. And what remains will be our conjugate base. So F- is my conjugate base. Same thing down here with acetic acid. I think about this as H+ and the acetate ion, because I've memorized my polyatomic ion, so I recognize that as the acetate ion. I know that these H's are not acidic because they're not written in the front of the formula. And so I'm just taking off this H+, and that leaves me with the acetate ion as my conjugate base. H2CO3 is a diprotic acid. I have 2 hydrogens there. To figure out the conjugate base, I just need to take one of them off, and so I will subtract one and make HCO3, and I've taken away an H+ from something that was neutral. And since that's the case, I must have a negative as charge on my remaining ion.